Welcome to the deep dive. If you're looking for that shortcut to becoming truly well-informed, to grasp complex topics quickly, thoroughly, and without feeling like you're drowning in information overload, well, you are absolutely in the right place. Today, we're taking a deep dive into Java sealed classes. They're a powerful, pretty modern feature that brings some really exciting control and clarity to Java programming. Our mission here basically is to unpack what these sealed classes actually are, why they were even introduced, the specific problems they solve, and maybe most importantly, how they can make your Java code more predictable, maintainable, and robust. We've pulled some great insights from a comprehensive guide on this, so let's just jump right in. So let's maybe set the stage a little bit. When we think about traditional Java inheritance, sometimes it feels a bit too open, doesn't it? Like you design this really nice architecture, but then, whoops, anyone can just come along and add a new subclass, maybe extend things in ways you never intended. It can lead to unexpected behaviors or, code that gets really fragile down the line. It's almost like you want to control your family tree, but any distant cousin can suddenly show up and claim a room.
That's a perfect way to describe it. It really highlights the core design issue that sealed classes were meant to fix. They came in with Java 17, JEP 409, remember? And for those who don't know, JEP is just Java Enhancement Proposal. It's basically how new features get planned and added to Java. The fascinating thing here is that they give developers really fine-grained control over that inheritance. Our source material actually uses a great analogy. Think of a parent who decides exactly which subclasses are allowed to inherit its traits. It ensures this tightly controlled family tree for your code. And this kind of explicit control, it helps prevent those unauthorized or just unexpected subclasses, making your whole class hierarchy way more predictable. Maintainability becomes like a built-in feature.
That sounds incredibly valuable, especially for preventing those surprise moments you sometimes get in production code.
Okay.
All right, let's unpack this then. How do these sealed classes actually work? What are the mechanics? Is it just sticking a keyword somewhere, or is there a bit more going on?
It's definitely more than just a keyword. You can think of it as a contract, one that the Java compiler actually enforces. The core mechanic is pretty straightforward, actually. You use the sealed keyword when you declare a class or an interface. And then, this is the important part, you add a permits clause. This clause explicitly lists every single class or interface that's allowed to extend or implement the sealed one. It's like drawing up an exclusive guest list for your class's inheritance party.
Ah, okay, the guest list. I like that.
Exactly. And beyond that, there's a crucial rule for those subclasses you do permit, the ones on the guest list. They must be declared in one of three specific ways. First, they can be final. That means they're the end of the line. Nothing can extend them further. Second, they can be sealed themselves. So they continue the controlled lineage, defining their own permitted subclasses.
Right.
Or third, they can be declared non-sealed. Now, this one essentially opens the door back up. From that point on, that non-sealed subclass can be extended by anything, like traditional inheritance.
Okay, wait. So if a permitted subclass is non-sealed, doesn't that kind of open the family tree right back up again from that specific branch? Are there situations where you'd actually want that flexibility, even if it sort of seems to go against the main idea of sealing things? It feels a bit like installing a fire escape hatch.
The fire escape hatch, that's a really good way to think about it. And you're right, non-sealed does seem a bit counterintuitive at first, and it definitely mitigates the strictness. But it has its uses, its niche. You might use it if, say, you want to define a fixed known set of immediate children, but for one specific branch of that family, you anticipate needing more open-ended growth later on. Maybe you have a sealed payment method that permits credit card, PayPal, and crypto payment. But maybe that crypto payment subclass itself needs to be non-sealed because, the crypto world is constantly changing, new types popping up all the time. So it gives you a kind of pragmatic way to mix that strict control with some limited flexibility. But, like you said, you have to use it carefully because it does weaken the main benefit of having a fully sealed, predictable hierarchy.
Gotcha.
The really key thing, though, is that the compiler checks this whole structure. It ensures the entire inheritance hierarchy is fully defined according to your permits clauses. Only the allowed classes can join the party. This makes it much easier to reason about all the possible subtypes. Oh, and as a nice side benefit, sealed classes work really, really well with Java records. You can create some very concise, immutable data hierarchies that way.
Okay, right. This is where I think it gets really interesting for, the everyday developer listening.
Yeah.
We've talked about the problem they solve, the mechanics.
Yeah.
But what are the biggest advantages? Why should you, our listener, really care about potentially using sealed classes in your next project? It sounds almost too good to be true for certain kinds of modeling. But maybe first, what's the biggest kind of trade-off or challenge a developer faces when they decide, okay, I'm going to use sealed classes here, even before we dive into specific pitfalls?
Yeah, that's a great question because it's not automatic. It's a deliberate design choice, and there are trade-offs. The biggest advantages, though, really boil down to two things: controlled extensibility and clarity. First, they stop those unwanted extensions we talked about. They act like your firewall against unexpected additions messing up your carefully designed system.
Right, the chaos control.
Yeah. Exactly. Second, they make your design intent crystal clear. That permits clause explicitly lists the only valid subclasses. Anyone reading the code instantly understands the intended structure. But connecting this to the bigger picture, I think the major aha moment for a lot of developers, and honestly the core reason you'd reach for them, is how perfectly they work with Java's pattern matching features.
Ah, pattern matching. It also came in around Java 17, right?
Yep, also Java 17. And this synergy is not just like a neat little trick. It's the magic ingredient. It transforms sealed classes from just a way to control inheritance into a practical, compiler-enforced safety net. When you use sealed classes with switch expressions or the newer instance of checks, the compiler can perform exhaustive checks. Because the compiler knows all the permitted subclasses for a sealed type, it can actually verify that your switch statement or your checks cover every single possible case. Yeah. It completely eliminates a whole category of runtime errors we used to get from forgetting a case in a switch. I remember this one bug years ago in a payment system. An unexpected subclass caused absolute chaos. If we had had sealed classes then, the compiler would have just said, nope, you missed a case, or nope, that class isn't allowed, boom, bug prevented.
It's huge.
It is. It makes them absolutely perfect for modeling those fixed sets of types you often find in domain models. Think about shapes, right? A shape could be sealed and permit only: circle, square, triangle. Your switch that calculates area must handle all three. The compiler guarantees it. Or payment types: credit card, PayPal, direct debit. Or employee types: manager, developer, intern. So ultimately, yes, they boost maintainability, robustness, even security by limiting who can extend things. Now, the main trade-off you asked about before we get into pitfalls, it's that upfront design cost. You have to think through the hierarchy. You're consciously choosing to limit future flexibility for current clarity and safety.
That is incredibly powerful, especially the switch part. My mind immediately goes to getting rid of those horrible default cases that just swallow everything and maybe hide bugs. It's like the compiler becomes your safety partner, actively telling you, hey, you must handle this specific possibility, which, yeah, that sounds like a dream for building reliable software. But for those of us who like peeking behind the curtain, what's actually happening under the hood?
Yeah.
When you compile and run code using sealed classes, what's Java doing differently?
Well, the Java compiler is really the star player here. It's doing the heavy lifting. When you declare something as sealed, the compiler meticulously checks every single subclass you listed in the permits clause. It verifies their valid types, that they're accessible where they need to be, and, crucially, it makes absolutely sure that no other unpermitted class tries to sneak in and extend your sealed type. You can really think of it as the compiler enforcing a strict contract on your class hierarchy. And internally, how does it know? Well, sealed classes get compiled with extra metadata in their bytecode. It's like a little tag or marker that the compiler and the Java runtime understand. This metadata is what they use for all that enforcement and also to enable the smarts behind that exhaustive pattern matching we were just talking about. So yeah, it's not just a suggestion to the programmer, it's baked right into how Java processes and runs your code. And one more thing, particularly relevant for larger modular applications using the Java Platform Module System, or JPMS, sealed classes can even add another layer of encapsulation there. You can restrict the permitted subclasses to reside within the same module as the sealed parent. This really tightens up boundaries and enhances security, helping you build truly robust, well-defined components.
Right, that makes sense. But this does bring up an important question. Sealed classes sound incredibly powerful, almost like a perfect solution for certain problems. But new features, powerful features, often come with, let's say, considerations or potential downsides. What are the potential pitfalls? What are the things someone just starting out with SEAL classes really needs to keep in mind? Where might they trip up?
You're absolutely right. They're not a magic wand for every situation. Understanding the limitations is key. Probably the main one is that restricted flexibility we touched on.
Hmm.
By design, they limit extensibility. If later down the road you realize, oh, I actually do need to allow other unforeseen types here, well, you might have painted yourself into a corner.
Right.
And while non-sealed offers that escape hatch, remember, using it kind of dilutes the main benefit. So it's a trade-off. Another point is definitely increased design complexity, especially up front. You really have to plan out that hierarchy deliberately. For beginners, that can feel a bit more daunting than just creating regular classes. Then there are considerations around modularity, like we just mentioned. If you're using modules, the permitted subclasses need to be accessible, which usually means they end up in the same module, or at least the same package, depending on visibility.
Okay, yeah.
For beginners specifically, there's definitely a learning curve. Sealed classes, especially when you start combining them with records and pattern matching in switch expressions, well, it's powerful, but it's a set of newer, more advanced features that take a little time to really wrap your head around. And finally, just acknowledging they have somewhat limited use cases. They shine when you have a fixed, known set of variations for a concept. They're much less useful for hierarchies that are naturally open-ended or expected to evolve dynamically. In those cases, traditional classes or interfaces are probably still the better tool. So for you listening, if you're just starting out, my advice, start simple. Model something straightforward with a fixed set of types, like shapes or maybe those payment types. Don't try to refactor your entire legacy application on day one.
Good advice.
Really get comfortable with that permits clause and understand the difference between making a subclass final, sealed or non-sealed. Those choices matter. Definitely try to use them with pattern matching. That's where you'll see the immediate safety benefits and often write less code. Explore using them with records too, especially for simple data carriers. They're a natural fit. Think about modules if that applies to your project, and test. Make sure your pattern matching really does cover all the cases the compiler now knows about. But maybe most importantly, know when not to use them. If you need open-ended inheritance, don't try to force a sealed class structure. It'll just cause headaches. Use the right tool for the job. And, it sounds basic, but really dig into the official Java documentation. It's quite good on these newer features.
Okay, so let's try and wrap up this deep dive. Java sealed classes essentially give you a way to create these controlled, predictable inheritance hierarchies. They're like that firewall against unexpected code chaos, as you put it. They boost code clarity, improve type safety quite significantly, especially because they integrate so well with modern Java features like pattern matching, giving you those exhaustive checks. They sound ideal for modeling fixed domains when you know exactly what kinds of things should exist within a certain structure. But, and this is the key takeaway maybe, their restrictive nature means you really need to design carefully and understand why you're choosing to seal something. So what does this all mean for you? Well, think about how understanding when, and importantly how, to use sealed classes appropriately can help you build genuinely robust, more maintainable Java code. It's really about giving you the power to avoid common problems, like designs that become too rigid later, by making very conscious, deliberate choices about where and how your classes can actually be extended.
It's a powerful tool in your Java toolkit for crafting software that's flexible where it needs to be, but also predictably stable where that really matters most. Ultimately, making your code not just work, but hopefully be a bit more of a joy to work with too.